So now what we're going to do, we're going to look at an example of how to construct one of these frequency tables using these intervals or classes, how we come up with it on our own. So let's take a look at some data. And the data I'm going to use, they're the high temperatures for each day in the month of January, this past January. So let's take a look. So January 1, I'll list the days here. So for the first 6 days, 61 degrees, 46 degrees, 51, 67, 64, and 42. Sort of a typical spread, if you will, various temperatures for highest temperatures. Remember, these are the highest temperatures on a given day. So on the 4th of January, the highest temperature was 67. On the 6th of January, it was 42. All right. So on the 7th, it was 58. On the 8th, it was 74. 9th, it was 48. On the 10th, it was 50. On the 11th, it was 56. And on the 12th, 64. So those are the next 6 days. All right. So I'm going to erase these. So the 13th, we had 42 as our high temperature. On the 14th, 75. 15th is 50. 16th is 67. 17 is 63. 18 is 70. 19, 20, 21, 22, 23, 24. So let's see, on the 19th, 51. On the 20th, 34. So you got 75 and 34 as high temperatures in the same month. All right. 53, 47, 62, 24. Got 51 for 28th, 59 for the 29th, 54 for the 30th, 68 for the 31st. I have the 60 degrees for the 25th, 42 for the 26th, 53 for the 27th, 51 for the 28th, then 59 for the 29th, 54 for the 30th, 68 for the 31st day of January. All right. So this is the data. We're going to break this up into intervals, and we're going to figure out how to do that. So we're going to follow the advice in the text. So first off, what the author suggests is this. Select the number of classes. We're just going to select them. Now, there is a formula the author mentions that's kind of complicated, and they say, we're not going to worry about that for now. So their recommendation is choose somewhere roughly around 5 to 20 classes. So about 5 to 20 classes. And I'm just going to choose 5. So I'm going to choose n, my number of classes is 5. All right. Next, we're going to compute the class width. Now, in this case, there's sort of a formula for this, and it's going to be this. Now, we don't have any intervals constructed yet. They're not constructed yet, so we can't take the difference of the two lower class limits. That's what we were doing last time. We got to come up with this from scratch. So what it is, we take the max data value subtract the minimum data value. Now remember, we don't have any intervals yet. We don't have any classes. So this is just the max data value of all of our data, which I think is 75. And then the minimum data value was 34. So we do that, and then we divide by the number of classes we decided to have. So in this case, what that comes out to (75) minus 34 over 5. And this comes out to 8.2. Now, I put an approximate here. What I end up doing is I tried constructing my classes using 8. I rounded down. The author recommends use convenient numbers. So the first thing that I did is I rounded 8.2 down to just 8. And when I constructed my classes, they turned out to be too small. And what happened was that after I constructed 5 classes, they weren't wide enough to capture the highest temperature values. There were some temperature values still beyond my 5th class. They were greater than my last or my 5th class. That means I would actually need 6 classes to capture the data if I used 8. Now the author recommends rounding up. So what I did is instead of using 8, I used 9 instead. And when I did this, all of the data fell into the 5 classes. I didn't have to add some sixth class. And I mean, if I make it n equals 6, I got to go back and do my division all over again, calculate my new class width. So what I did is I just used a wider class width. And again, I got this idea from the author who was saying round up as opposed to down. And it worked in this case. So just passing that on. Sometimes if you round to the nearest whole number, you might be rounding down, and that might make your class width too small. So I rounded up to make sure my class widths were big enough so they could contain all the data. All right. So that's our second step. So I'm going to use a class width of 9. The third step is we're going to choose the first lower limit. So what I did here is I just used the smallest value of all my data values. So that's where I'm going to start. That will be the lower class limit for my first interval, or my first class. And again, the author says use convenient numbers. And I mean, you could try 30. Now, I think I did try 30. And again, I ran into some issues where my classes, even with a width of 9, I don't think they quite covered. Honestly, I don't remember. But it might have been that 30 was too low. And in that case, using 34 allowed me to create classes that captured all the data. So that's something to keep in mind. So anyway, this was a number that worked. So I'm going to go with it. I might have used 30 with the other limit of 8. I don't recall, but for some reason, 30 didn't work. Okay, so I'm going to go with 34. I'm going to use my smallest data value to start the lower class limit of the first class. So we're going to do this. Now we can construct our classes. Fine. So we're going to take that class width, which was 9, and then we're going to add it to our first lower limit. And then we're going to continue this process. So we're going to use this to generate our 5 classes. So what do? Well, we take our first lower limit. I'm going to circle it. And then we add the class width, 9. And so that is going to give us 43. What this will be, if you think about how we define class limit, class width. The class width is the difference of consecutive lower class limits. So if we took 43 minus 34, we're going to get 9, the class width. So this, I kind of skipped ahead here, but this is implying, by adding the class width, this is our next lower limit. And you can check this, because this lower limit minus this lower limit, of course, you're going to get 9. So the other way to think about it is you take a lower limit, add the class width, you should get the next lower limit. So we're going to repeat this process. Take the lower limit now, add 9. We're going to get the next lower limit, 52. Take this lower limit, add the class width. we'll get the next lower limit, 61. Take this lower limit, add 9, we get the next lower limit, 70. Let me make sure. And then we take this lower limit, add 9, we get this lower limit, 79. And so this is going to give us, well, it's going to give us our classes. Almost. So let's take a look at what we've got. So far, we have 34. And we don't have an upper limit yet. We have a 43. We have a 52. And then we have a 61. And then we have a 70. And then we didn't need to go to the 79. That was one too far. We only need the 5 classes. I accidentally did the 6th one, but we don't need that one. We just need the 1, 2, 3, 4, 5 classes. So this last calculation wasn't necessary because we only have 5 classes. All right. So now what we got to do, we got to choose the upper limits. And the author really just kind of says this. And okay, fine, fair enough. So we'll choose the upper limits. So what should be a limit between 34 and 43? And I don't know, I might say 42. Say 42. And then between, so we have a, let's see here, so we've got a 52 here. And what could we put there? Well, we could put a 51. And then for this one, we could put a 60. For this one, 69. And then for this last one, we might notice a pattern. The difference between lower and upper class limits is 8. The difference is 8. So that sort of suggests that that would be 78. So, well, there you go. We chose some upper limits. And granted, it seems kind of arbitrary. One thing I did keep in mind when I chose these, like why wouldn't I use 42.9? And the one thing I knew was that my actual data, even though these are intervals, my actual data are whole numbers. And the way I've chosen these upper boundaries, since I don't have anything like a 42.5 as part of my data or a 42.3, I have the data landing in these classes if I just use whole number upper class limits. So all my data is going to end up in one of these 5 classes. It's not going to end up in the gaps. So it was okay to choose like, okay, the integer that's close to this lower limit. And I chose 42 since the lower limit for this class was 43. The lower limit for this class is 52, so the nearest integer is 51. The lower limit for this class is 61, so I chose the closest integer of 60. lower limit for this class is 70, so I chose an upper limit. The nearest integer is 69. And the way these have been chosen is I don't have any data falling in the gaps. So anyway, something that I just wanted to make sure would happen. Anyway, so let's actually start constructing our frequency table. So we're going to look at tallies. So how many temperatures were from 34 to 42? Well, turns out there were 1, 2, 3, 4, unless I miscounted. I hope I didn't. 43 to 51. 1, 2, 3, 4, 5, 6, 7, 8. Temperatures that were 52 to 60. Well, there were 1, 2, 3, 4, 5, 1, 2, 7 of those. From 61 to 69, 1, 2, 3, 4, 5, 1, 2, 3, and 4. And then 70 to 78, 1, 2, and 3. So now we can construct the frequency table. So highest daily temps, and then how often different temperatures fell into different temperature intervals. Our first interval, 34 to 42, 43 to 51, 52 to 60, 61 to 69, 70 to 78. So looking at our tally marks, what we had, 4, 8, 7, 9, and 3. And so that's our frequency table. Now we can calculate boundary points if we like, because we know what the lower and upper class limits are. And we can come up with the class width. For example, this low, if you want to find the class width for this class, you take its lowest class limit, subtract from the next low class limit, 43 minus 34, of course you get 9. For this class, you'd subtract this low class limit from the next low class limit, 52 minus 43, 9. For this class, you want to find its class width, take its low class limit, subtract that from the next low class limit, you get 9. And, well, for this class limit, or this class width, I'm sorry, you take its class lower limit, subtract from the next class lower limit, and we also get 9. So we're seeing this pattern. All right. So for boundary points, again, those are going to be points in the middle of the gaps for this example. So what we're going to do with those will turn out to be 42.5, 51.5, 60.5, 69.5, and then finally the lowest boundary point, 33.5, and the highest one, 78.5. So for example, if we take a look at this class, the boundary point, again, the gap is 1 unit across. The boundary point we're putting in the very middle. So the point between 42 and 43 is 42.5. And what we're going to see in this example, as well with the other gaps, it's 0.5 from 42, it's 0.5 from 43. So that kind of suggests the boundary points are 0.5 away from the adjacent class limits. So that means this one will be 0.5 away from this adjacent class limit. It's going to be 33.5, which we have right there. And then for that last class, again, we'll put a boundary point at the end here. This is the one that we could figure out. So this would be 69 here. Then there's the rest of the class, 69.5. Again, 0.5 away from each of the adjacent class limits. So this also needs to be 0.5 away. We'll call it 78.5. So that gives us our boundary points. Finally, the midpoints. Now, these are just the averages of the upper and lower class limits for each class. So we're going to find 5 midpoints, one for each of our 5 classes. For the first class, lowest value, the lower limit plus the upper limit, divided by 2, we got 38. And then, 42. So that's 42, not 43. Next one's going to have a 43. So again, lower class limit, upper class limit for the second class, and we get 47. And then for the third class, lower plus upper divided by 2, and we're going to get 56. Fourth class, lower plus upper divided by 2. There's your midpoint. And then finally, for the fifth class, and there's the last midpoint. So that's constructing a frequency table by Scratch. If you have any questions, let me know.